Yeah, we're live, and we're back at day 18 again. What the hell? So after my absolutely atrocious 8-hour run around with this stupid puzzle, doing everything wrong, and then just crying, well, I felt like I was crying, and not eating supper and all of that stuff. Don't code while on an empty stomach, because you essentially just do what I did. And ever since then, I learned. I'm not gonna pretend like I found this on my own, because yeah. But I learned of a significantly better way to do things. Things that make things so much. Well, it makes you not want to cry. Except for the fact that I didn't do this on the first time, which does make me want to cry. But we'll take what we can get. So we're gonna take advantage of a couple of math theorems. First, let us just capture this so I can move it into a drawing program. Recent screenshot. We'll move the paint layer. We'll move the paint layer above. Thank you. Alright, and use straight lines here. Don't want something nearly that thick. Not that thin either. 2 points. Yeah, that works good. Just pick a good color. We'll look at that. Yeah, that looks good. Okay, so we actually don't want entirely opaque. Actually, well, for now we want opaque. Okay, so here we have a polygon, and let's just draw it. Oh wait, there's a little polygon tool. Get this up. Tool options. And not fully opaque. Will this work? So ignore my inability to draw straight lines. Oh no, that went back the entire. No. Oh, this is kind of atrocious. So we have this polygon here. So what was one of the issues we were having before? Was that this area in red? Just call this like A. This represents. Well, again, this represents the internal area. But what we want is that we actually don't want the area. We actually want to count, like, okay, we count 1, 2, 3, 4. We essentially want to count the number of pegs. Now, there's actually a really cool formula that's relating to the area of a polygon as well as counting of the integer coordinate points. So we go back to Firefox, we get Pick's theorem. And Pick's theorem says that for a polygon whose vertices are integer coordinates, there's a really cool theorem which pretty much says the area is the number of internal points plus half the amount of boundary points minus 1. So we'll just write that down here. Equals, we want, return to black. A equals number of internal points plus half of the boundary points plus 1. No, minus 1, sorry. Now, it's what we're actually looking for. We're not looking for the area. What we're looking for is we're looking for the number of internal points plus the number of boundary points. That is what we're actively looking for. So to find that, well, the number of boundary points is literally just counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like, we just count around the edges. Very easy to do. We have the numbers already. So, trying to extract everything else out, we want to get the internal and okay, sorry. Hold on. So let's just swap these around just to make the math easier. So we have I plus half the boundary equals A plus 1. And if we want to add half a boundary, plus boundary equals area plus half the boundary plus 1. Now, we already know how to get... Come on. We already know how to get the boundary. Well, so we either need to find the internals, which is essentially what the problem is asking about, or find the area. The thing about finding the area is the significantly easier thing to do. Because, again, there is another formula we could use. So, hold on. Let me go back to here. This is Pick's theorem. And now we get to use another theorem, the shoelace formula. Basically, the shoelace formula is a way of getting an area of any arbitrary polygon. Now, there are many techniques to do this, to find this area of this. My personal favorite is the trapezoid formula. Oh, hold on. Basically, the idea of the trapezoid formula is, first you have a concept of assigned area. So here, if the top edge goes left, that's positive. If the top edge goes right, that's negative. So if we take this trapezoid here, the one formed by P1, P5, and the x-axis, we have this large trapezoid here. But you notice that the bottom part will end up being subtracted because the trapezoids of this line and this line. So basically what ends up happening is if you take this entire top thing, but then just only lop off the bottom parts, we get only the area of the top part. And by doing this all around, you'll see that everywhere inside is essentially just this is positive, or at the very least one more positive than there is negative, and everything on at the bottom here has equal number of positive and negatives, so that they get cancelled out. So by basically taking the sum of the areas, or essentially half the sum of the y positions times the difference of the x positions. We sum that, get all the areas of trapezoids, add them all together, cancel stuff out. You get the area of the polygon. So now, shoelace. is the area equals the sum of I equals... Now we're going to start from 0 to n minus 1, because this is with like mathematical indexing, which starts at 1, when in reality we want computer science indexing, which starts at 0. So we have yi plus yi plus 1 times xi minus xi plus 1. Now, I know here we have it so that if it's the direction goes left, it's positive. If the direction goes right, it's negative. However, that's ultimate. Like, what if our polygon does go in the opposite direction? Well, we'll still get the area of here, but just the negative area. So to get the final area, we just take the result of this and then get the absolute value of it. So regardless of orientation, the absolute value should give us the right answer. So oh, and this is, sorry, it's half of all this. So now we have the area, we have B, which means we could find what I plus B is equal to. And, yeah, so last night when I was mucking around with this, I created a very simple polygon class. You give it a list of points, and using that formula, it can grab the area. So, let's rewrite our day 18 using this new polygon class. And just because I like to keep track of all my old solutions, we're just gonna copy paste this and cool. So let's go all the way down to part 2. Oh, actually, no, I have to go to the top. Include polygon. So we have our position, so we have p.points, and place back position 0 and position 1. We'll keep the movement update for now. And everything else below here is just whatever, so turn. Oh, so we want to get the boundary points, so long boundary equals 0. Boundary plus equals inst dot color. And so we have long of p dot area plus boundary over 2 plus 1. Redef percent LD LD res 2 Oh boy, that's a lot of new code. Let's just compile 2023. Code 18 part 2. And there we go. That's the answer. It's that simple. It's that simple. So, I guess we can also use this for part 1. I see. Okay, hold on. Distance, 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 distance. And it does this work. God, isn't that so much easier? Look at all this code. I could just go boop. Don't need these anymore. The best part is we could just fucking kill all of these functions that are just no longer being used. Tier 2? Or Tier 2? What's that? Move and update. Fucking die. BFS inside? Who needs BFS? Find first inside. No thank you. We still use move. And this is just all parsing. Tutor is, we still need that. Well, yeah, just fucking infinite, all that work I did on the infinite grid class. Fucking useless! Now, in theory, perimeter should also work here. I just had this not work a couple times. Oh, right. And then... yeah, my perimeter code seems to not work. Okay, I have another function which in theory should also be the perimeter, but it's specifically for flat, for non-curved things, but apparently isn't. Yeah, I don't know what's wrong with my perimeter code. I think I might have made a bug on my perimeter code somewhere. Oh my god, Ninja 2023. And because these are so similar, I am like dedicated. I must generalize these. Fuck, how do you do pointer to member function arguments? Again. Or pointer to, sorry. No, not pointer to member function, pointer to members. Oh, right, I still need to do the type, so, yay. Oh, Because I'm literally dividing by 2 here. Am I dividing by 2? What the fuck? Oh, because I kept it from there. That's why. Oh my god, I hate myself. And why are you complaining? Yeah, I know it's... That's the idea. Fine, static tasks long. Nothing really make much of a difference, but... Oh, shut the fuck up. Oh, that's why. Yeah, I definitely feel stupid for what I did here. Like, oh my god. Anyway, yeah, that's it. That's the result. That is how you do it properly. End stream.